Hey, welcome. Today we're going to be talking about how to convert from mass in grams into atoms or molecules. And we're also going to talk about the mole-volume relationship, conversions with that as well. So maybe you're a chemistry or a physical science student and you need to know how to do problems like this. I'm going to show you exactly how to do them. And at the outset though, I do want to say that I've gone over how to do mole to atoms or molecules conversions in a little more detail, and I'll put a link to that in the upper right now. I've also gone over moles to mass conversions back and forth as well. This is called molar mass, and I'm going to show both of those today. So if you just need a refresher on some of those ideas, you're going to see them worked out today. Alright, let's go ahead and get to it. First of all, we do have a new equivalency. So an equivalency would be where we can set things equal to each other, and we know that they're true. Like an equivalency could be 60 minutes is equal to 1 hour, or 1 dozen is equal to 12 objects, 12 of whatever it is we're talking about. In a similar way, we can make a new statement and say that 1 mole of any gas, doesn't matter what the gas is, takes up the same amount of room at standard temperature and pressure, the same amount of volume of 22.4 liters. What is standard temperature and pressure? Well, we define that as 0 degrees Celsius, which is pretty cold, but also 1 atmosphere, and that's about the atmosphere that we experience in our everyday life as we're just walking around, the amount of air pressure on us. Or you could say that is 101.3 kilopascals. So at that standard temperature and pressure, we can make this statement that 1 mole of any gas is equal to 22.4 liters right here. So let's see how to apply this though. How would we do a problem with this? The question is, how many liters of volume does 2.34 moles of hydrogen gas take up at standard temperature and pressure? You will see problems like this if you're in a chemistry class. Alright, so think about how you would set up this problem and see if you come up with the same answer that I do. What we're going to do is start with our given value. So we start with 2.34 moles of H2 gas over here. We're going to multiply that by an equivalency that is equal to 1. I know that 1 mole of H2 gas is equal to 22.4 liters. I know also that since I have moles of H2 gas over here, I need moles of H2 gas in the denominator that is equal to 1. So we can cancel out our moles of H2 gas here and end up in liters of H2 gas. And if you're doing this correctly with units along the way, you can see that what you're left with here are liters of H2 gas, and that's what we need from the problem. So units can help you spot mistakes before you commit to your answer on a test, for instance. Alright, well let's see how it works in the other direction. So we could say another problem I could give you would be how many moles of Cl2 gas, it should say, is 77 liters of Cl2 gas at STP. We're going to start by writing our given value over here, and because we have liters of chlorine gas over here, we need liters of chlorine gas in the denominator of our fraction that we're multiplying our given value by. And the equivalency is from liters into moles of this gas, and so the liters will cancel out and we end up with our answer in terms of moles. So as you can see, it's really not that tough. It's just like a one-step conversion to go from moles into volume of a gas at STP or volume of a gas at STP back to moles. One-step conversion, no problem. Alright, well let's try something a little harder. Let's try a multi-step conversion. So jumping from one thing to another. So this question says, what is the mass in grams of 3.33 times 10 to the 24 molecules of sulfuric acid? H2SO4. So first of all, we could do the conversion from molecules into moles. The trouble would be when we go from moles into mass. We can't just look up on the periodic table and immediately know what the molar mass of H2SO4 is. We actually have to calculate that. And if you have trouble understanding what I just said, I'm going to show you how to do that. But also I put a screencast together that shows this in a little more detail. So H2SO4, the way we're going to calculate that is this. We're essentially going to think about what the molar mass of each of the components is, multiply it by the number of moles that we have for H2SO4. For instance, we've got 2 hydrogen atoms, 1 sulfur atom, and 4 atoms of oxygen in each H2SO4 molecule. So this is how you're going to do the molar mass calculation here, and you end up with a molar mass of about 98.07 grams for sulfuric acid, depending on how you round and what precision you take your answers. Alright, so we're going to take that work and build on it now that we know what the molar mass of sulfuric acid is, and go back to the problem. Alright, so what we're going to do here is start by writing our given value, and because this will be just so wide if I write it out in the same style, I kind of condensed this, but this is all in the numerator for the first term that we're looking at. And we have molecules of H2SO4 over here, so I need molecules of H2SO4 over here. We're going to convert from molecules, so over here, into moles, and then from moles into mass. That's what we're doing. So we convert from molecules into moles, and then we're going to convert from moles into grams of H2SO4. These can cancel right here, and the moles can cancel as well. We end up with an answer in terms of grams, and it turns out to be 543 grams. And that's essentially how you would do one of those problems. So I want to summarize our strategy though. So the first thing you're going to do is write out the given value and the units for the given, like 3.33 times 10 to the 24 molecules of H2SO4. Then what we're going to do is set up the first equivalency as a fraction that is equal to 1 with the same units in the denominator as the given. In other words, we need to cancel out molecules of H2SO4, so we need to have molecules of H2SO4 in the bottom of the first fraction that we're using based on an equivalency. And then you just continue that process. In this case, we needed to make two jumps. We needed to have two conversions here. So we had to go from molecules to moles and then from moles to mass. So you just continue doing this for as many steps as you need to cancel out units into your final unit. So you're looking for your final units, in this case, would be in grams of H2SO4. I've canceled out everything else in this problem and I end up with grams of H2SO4. That tells me it's time to stop the problem. And so that's it. It's that easy. It just takes practice, just like anything else. So if you have any comments down below, please let me know, and I hope you all have a great day.